Assalamualaikum. My name is Nadira binti Mazalan. My group members is Siti Hajar binti Arba'in, Anya Kalsum binti Sulaiman, and Muhammad Faris Mehmet Nazari. Today we would like to present that for continuous signal representation of Fourier transform. My part is to execute the coding. From this coding, we will find the output. First, we need to insert the first part. It is 10 seconds, and second part is 5 seconds. So here we can see the output from the coding that we execute. The first pulse and second pulse. This is spectrum for first pulse and spectrum for second pulse. Thank you. This is from me, Nadira binti Mazana.
I am Siti Hajar binti Ibrahim. My number matric is B0819108284. So for my part, I'm doing the question 1 and question 2. For the question 1, we need to define the Fourier transform. The Fourier transform is a mathematical function that takes a time-based pattern as input and determine the overall cycle of set, rotation, speed, and strength for every possible cycle in the given pattern. It integral transformation of ft from the time domain to the frequency domain. So for the question 2, we need to write down the general function for rectangular function and sin function. So for the rectangular function, the general function is rect t1 t less than 1 over 2 t is equal to 1 over 2, and for 0 t is greater than 1 over 2. So for b, sin function sin t, we have two types. So first, unnormalized sin t. Sin t equal to sin t over t. And for normalized sin t is sin t equal to sin pi t over pi t.
Hello, my name is Aina Kalsom. My task is question number 3. Draw graph manually plus for FT and GT and their frequency spectra. Label your graph and show your calculation. Follow the example in figure 2 and figure 3. This is figure 2, the GT and the FT. And this is figure 3, G omega is given as shown. And I need to find the F omega from FT. And this is graph that I do manually for FT. We get negative 5 to 5, while D is frequency spectrum, and I will show how to get the result for F omega. By using the Fourier transform formula, and we try to solve and simplify the equation, insert the negative 5 to 5, and then we solve the equation. We must get sin cx is equal to sin x over x, so tan sin omega 5 over omega 5 is equal to sin cx equal to sin x over x. The result is we get tan sin c omega 5. This is proof that tan is our spectrum frequency, and sine C omega 5 is our sine wave. Next, I will show about GT. It will start with negative 2.5 to 2.5. Given that GT is F2t, and we solve the equation and we get F equal to 1 over 2. To find the G omega is by using 2.5 from our graph. 2.5 is equal to 5 over 2. And we insert the 5 over 2 to the Fourier transform formula and simplify and solve the equation one by one. And then we must get sin Cx is equal to sin x over x. And when we solve it, therefore we will get the result 5 sin omega 5 over 2. So this is proof that our 5 is our f omega, while sin omega 5 over 2 is our sine wave. And that's all from me.
My name is Muhammad Faris bin Mat Nazari. Number ID B0819104008 from BET 1 S1 slot 2. For lab 4 continuous signal representation of Fourier transform, I will tell you about the question of the number 4 and the conclusion. Okay. The question is, discuss your finding based on your result. Try to relate with time scaling property. So, I will go to the graph first. Okay, this one. On the upper left row is a graph of the pulse function of unit ft, and below is the Fourier fw of f omega transformation frequency function. Translation, i.e. delay, in the time domain is interpreted as a complete phase shift in the frequency domain. And the upper right row is shown GT, the pulse of the delay unit, next to the real and imaginary part of the Fourier transformation. The Fourier transformation parses a function into a eigenvalue for a translation group. The imaginary part omega is reacted because the negative sign exponential has been used in the Fourier transformation, which is the default as is originate in the Fourier series, but the sign is not essential for a transformation that will not be reserved. And the last is frequency spectrum for second pass. The graph it will show like this. And the conclusion, on this lab activity, we have learned how to show the signal representation of the Fourier transform and able to run the simulation using MATLAB software. Besides, we learned how to study the coding to represent the signal by the function given and all the data have been given. Furthermore, we learn more about the Fourier transform, which transform time domain ft to the frequency domain f omega when we get the signal for the function given in this lab sheet. Then, we also have learned how to make a calculation by referring to the graph we get and how to study the graph to get the value. Lastly, we are able to accomplish this lab activity by using MATLAB. So,